Click the bell icon to get latest videos from Ekeeda.
Hello students. So after covering many problems on inverse hyperbolic function, I'm going to start with a fresh problem on the same concept. So here we'll see how to prove the result by using the different formulae of inverse hyperbolic function. So now here we have to show that tan inverse of I x minus a upon x plus a is equal to I by 2 log of x by a. Now guys, if you observe, then here there is no inverse hyperbolic term. So if we don't have the inverse hyperbolic term, then how we'll solve it by using the formula of inverse hyperbolic function. So guys, that formula is not present here right now, but when we'll solve this problem, we'll go ahead with few steps, then we might require the formula of inverse hyperbolic function. So let's start. Now guys, how to solve this? So if you observe, then we have to prove the value as I by 2 into log of x upon a. But initially, since we don't know the value of this term, we'll assume it as theta. So here I'll say let tan inverse of I x minus a upon x plus a equal to theta, and then by moving ahead we will prove that the value of that theta is I by 2 into log of x upon a. Now guys, to prove this value, we'll move ahead. So I'll move this tan inverse on the right hand side. So we'll get now to get this value, we have to substitute few formulae of trigonometry. Now for tan theta, there are many formulae present. Now the question is which formula we will use. So guys, since in the answer we want log term, so we have to use some formula of tan in which log comes or exponential term comes, because then only it will be easier to bring the log term. So guys, we have the Euler's formula for tan theta. So I'll apply that formula. So the formula is like this. It is equal to now guys, this formula can also be derived by writing this tan theta as sin theta upon cos theta and then substituting the Euler's formula for sin theta and the cos theta. So if you don't know this formula, then I would recommend all of you to by heart this formula, because that's the relationship between the trigonometric function and the exponential function which is given us by the Euler's. Now using this formula, what happened is I've created the exponential term, and you all know that exponential function has a relationship with the logarithmic function, so that it becomes easier to convert exponential function to log or log to the exponential function. Now guys, let's solve it further. So I'll take this I on the other side, it will multiply this I, and that will be I square, which is minus 1. So we'll get negative of x minus a upon x plus a, which is equal to now guys, we can shift this negative sign on the other side. So this term will become negative and this term will become positive. So we'll get now guys, here we have reached till this term. Now let's again observe the question. So in the answer we want log of x upon a. It means by solving this we should get x in the numerator and the a in the denominator. But right now we have x and a both terms in the numerator as well as in the denominator. Now to eliminate a from the numerator and to eliminate x from the denominator, we will use the concept of componendo and dividendo. So that's the concept which will help us to eliminate a and x. So by componendo dividendo, we'll add this denominator in the numerator first. So let's see. So since I've added the denominator in the numerator, on the right hand side also we'll add denominator in the numerator. So we'll get So guys, by solving this, you can observe that a and a will be cancelled and we will get 2x. Now let's come back to the denominator. So in the denominator we have to do dividendo. So what we'll do, here we already have x plus a. Now if I take this term here and if I subtract that term from the denominator, then x will be eliminated and we'll get a. So here I'll say x plus a, which is denominator, minus the numerator, so that will become negative x and plus a. Similar thing we'll do on the right hand side. So we'll subtract the numerator from the denominator. So we'll get now guys, let's cancel the terms which are opposite in sign. So here x and x cancelled, then a and a cancelled. Here e to the power I theta and this negative e to the power I theta cancelled. Here e to the power minus I theta and this will be cancelled. Now guys, let's rewrite the remaining terms. So here we'll get 2x, here 2a. So 2 and 2 cancel. So we'll get x upon a. Similarly, here we'll get 2 times e to the power minus I theta. Here we'll get 2 times e to the power I theta. Again 2 and 2 cancel. Next this e to the power I theta will go in the numerator and we will get e to the power minus 2I theta. Now guys, since in the answer we want log of x plus a, so what I'll do is I'll take log on both sides. So therefore here we'll get log of x upon a is equal to minus 2I theta. So when we'll take log on both sides, so here log to the base e and this a will be cancelled and we'll get minus 2I theta. Now here we have assumed that the value of tan inverse I x minus a upon x plus a is theta and we have to prove that theta is this. So what I'll do is I will just keep theta on the right hand side and I'll shift remaining terms on the other side. So therefore we'll get theta as minus 1 upon 2I into log of x upon a. So guys, we know the identity of complex number and by that identity we can say that minus 1 upon I is I. So it will be I by 2 log of x upon a. And guys, here we got the value for theta. So we have proved the result and I'm sure you understood the method of this given question. So now you just have to copy down this same method, same solution in the exam to get the full marks. Also, let me tell you that to solve this question there are other methods are also available and we can use any of the method to get the solution. So guys, keep watching the videos and don't forget to subscribe to Ekeeda channel because here we are creating more videos on engineering mathematics and other subjects of engineering. Thank you very much.